Now let's look at using Python to do some confidence intervals. And we're going to take a distribution from the GPA data set.
Perfect.
So what I have is the GPA data set that we looked at earlier in this series. And I've went ahead and loaded in using df.pd.readcsv of GPA. And I used just a sample of this GPA. And we're not even going to load it in here because I'm just going to get some statistics from it. And we're going to work with those statistics. So I found that when I sampled 20 courses from the GPA data set, I got a mean value of 39.8 and a standard deviation of 6.8. So I have the basic statistics about my sample from this distribution. And my understanding is confidence intervals tell us if we have a population, here's a population of all UIUC courses, I am able to sample 20 of those courses from here, and we're able to talk about whether or not we think that the total number of students in the course of all UIUC courses is around 39.8, the mean of our sample.
Yes.
So the central limit theorem tells us that for a sum or an average of a distribution, the normal curve can be used. So in Python, we can model this as a normal distribution. So I'm going to go ahead and import the normal distribution by saying from scipy.stats import norm. And then I can go ahead and create the normal distribution. And here I want to create a normal distribution where we're not necessarily centered at 0 anymore. I don't want just a standard normal distribution. I want the normal distribution for this particular distribution. So I'm going to say d is equal to norm with a mean of 39.8, comma 6.8 for my standard deviation. So I have a normal distribution with a centered at 39.8 with a mean of 6.8.
Standard deviation.
Standard deviation.
Yes.
Yes. Perfect. So what I can do in Python is Python can actually give me the confidence interval given some confidence level.
Python just keeps impressing me more and more.
So it's great. So I don't have to do all the calculations. And if I have any sort of distribution, it can give me a confidence interval by doing d.interval and then in parentheses put the confidence level that you want. So for example, a 68% confidence interval is d.interval of 68. And Python's going to return not just one number, but two.
It gives me 33.04 to 46.56.
46.56. So what Python returned was the lower bound and the upper bound of this confidence interval. So this is similar to how you wrote this, Carly.
Exactly.
But you also wrote plus or minus. So if I want to find the plus or minus here, I would need to take the mean value, and I could say 39.8. And let's do the top range. So 46.56 minus 39.8. And what do we get?
Let's see. 46.56 minus 39.8. That gives me 6.76.
So this confidence interval is 39.8 plus or minus 6.76, or we can talk about the whole range, which the range is 33.04 to 46.56. And what this means, going back to our problem space, is that we are 68% confident that the true number of students in an average Illinois course is between 33 and 46, with 68% confidence.
Yes.
So let's go ahead and look at the 95% confidence interval. So in Python, we don't even have to think about the z-scores. We can just go ahead and say d.interval of 0.95.
That is so nice, because calculating the z-scores can be a little complicated. And I get an interval with a lower bound of 26.47 and an upper bound of 53.13.
So here, I have now a different lower bound and different upper bound, and this interval is wider. Is that what we expect?
Yes, we always expect the more confident we get, the wider our interval is going to be because our margin of error is going to get bigger. The z-score for 95 is going to be bigger than the z-score for 68.
Awesome. So let's see. So we now have another survey. And I'm going to set up the survey as instead of just having 20 people, maybe you and 19 of your friends, each in 5 courses, decided to survey all of those courses. So I'm going to simulate this by sampling 100 courses. So here, taking the sample of 100 courses, I used the exact same code, and this time I got a much larger mean.
Ooh,
I got a mean of 50.91, and a standard deviation of 7.1. So we see that that 50.91 is quite a bit different than the mean that I had up here. The mean was just 39.8, but this mean is within the 95% confidence interval. So
Ooh, that's true.
it's within the range of what we expect. So we're sampling a whole different set of courses, so we're going to expect a different result from our sampling. So when we do this, so here's a question that Python's not going to help us out with, but I think, Carly, you'll be able to help me out.
Yeah, for sure.
So what's the confidence interval we have when the true average class size is 59.91 plus or minus 7.1 students?
So 50.91 was our average,
Yep.
right? Our expected value, the average, and then 7.1 was just our standard error. So we're basically taking our sample average and adding and subtracting one standard error. And the z-score for 1, or when the z-score is 1, the confidence interval is 68%.
So here's our 68% confidence interval.
Yes.
So with n equals 20, our 68% confidence interval was, let's see, our 68% confidence interval up there was 6.76. So it was 6.76 students. But with 100 samples, our confidence interval actually, our 68% confidence interval actually increased to 7.1 students. I feel like this doesn't seem right. We had more samples, but now we have less certainty?
Yeah, so our sample size increased, so something else must have changed. So the only other part of the formula for the margin of error that could possibly change would be the standard deviation or the variance.
Yeah, so there's a few different factors that affect the confidence interval. So one factor that affects the confidence interval is going to be n. So that's going to be the number of people. And as n goes up, we expect the confidence interval, the width of the confidence interval, we expect the width to go down. That we expect it to get narrower and narrower. Because the more people we have, the closer we have the entire population. So as we get closer and closer to the entire population, we have more of an idea what the true sample should be. The second bit is, but we have this idea of variance, of how much spread there is in the data. So as the variance or the spread goes up, we're also going to see the width of the confidence interval go up as well. So what can happen here is if we get a really large course, there might only be a few large courses. Like I think there's only maybe 5 or 10 courses that teach over 1,000 students at U of I.
Right.
So we may have in our first sample not actually gotten one of those 5 or 10 courses. We got a lot of courses because a lot of the courses at U of I are pretty small. They're like 20, 30 students or small discussion sections. And having a 1,000-person course is quite rare. So I'm speculating that something like this may have happened, that when we got a 1,000-person course, it's a huge variance add to the data.
I think you're right, definitely. And that kind of explains why the second margin of error would be bigger.
And this also is reinforced by this idea that our mean went up by quite a bit, went all the way up to 50.
Right.
Seems to indicate that we picked one of those really large courses. And so what are the possible reasons that might explain? So we may have randomly surveyed a very large course only in the second set. And then one thing we can do is we can find out, using a GPA data set, we can find out the true average of the population. And I'm going to leave that for you to explore using the GPA data set. What is the actual average course of Illinois? And you can use all the Python skills you know to find out what the average course size at Illinois by loading in the GPA set that you already have access to. So I hope you nerd out with this and really see how close our confidence intervals were and how close our means were, how close was our guess to the actual true sample size of all courses at Illinois.
That sounds great.